All right, good afternoon.
Afternoon.
Good afternoon.
My camera is wacky. Newsflash. Let's try this. All right, cool. I think we're up on the air. All right. Any questions to start with? I got a bunch of stuff I want to go through today, but let's start with questions.
The presentations for the SLP going to be in person or remote again?
They're going to be remote. We're going to have a Zoom room set up, and it'll run from 3 to 5, and so you just show up. There'll be a list of room assignments, and you go into the room, and probably 4 people per room, and just take turns doing your presentation, and people will just come and go at their leisure. And I think that Zoom info has actually been on Canvas for a while. I think we set that up in the beginning of the term.
So it's going to be same format as last time, basically.
Same format as last time, yeah. But potentially more people showing up this time because it is, sort of the end of the year version.
Sure. As far as we're not turning in the project, we're turning in the report, right?
Correct.
So then we'll just show the project as it's at the presentation.
Yeah, so you can show the project. You can, show parts of your report if you have like cool pictures in there and stuff, or flow charts or whatever. You can use other materials in your presentation, and then so that's 50 points, and the other 50 points is your report submission itself.
Okay. And are we able to ask PA4 questions yet?
Absolutely.
So I have a quick question on mine specifically. You had made a comment that when you reset on player 2's turn, it doesn't always go back to player 1.
Right.
And I haven't had that issue, so I don't need the answer now, but if you could give me a general idea of how you got it to act up so I can fix that, that would be...
Yeah, so I don't know if it was yours in particular, but most of the times when I saw this, if you hit reset, the display went back to showing it was player 1. But if you go ahead and complete a box, the box gets credited to the wrong person. And it's like there were 2 notions of whose turn it was, one that was being displayed and one that was being used to give credit. The other version of this, which is even simpler, is that let's say it's player 2's turn, right? Instead of making a move, hit the reset button. The display says player 1's turn. You make a click, and then it still says player 1's turn. And it's like the reset changed the label, but it didn't change the internal Boolean that said whose turn it is.
Okay. Yeah, I'll have to do a little bit more into that, because I wasn't seeing that issue, but...
Okay.
You found it, so I
Well, try those, and if you don't see it pretty quickly, let me know, and I'll double check what I was doing, because it's possible, that once in a while a comment gets mixed up from one person to another. Because I grade these in batches, and I record all the comments in the file, and then I copy and paste into Canvas. So there's lots of potential for me to mess up. So
No, that's fine. Yeah,
if you don't see it pretty quickly, let me know.
Okay, sounds good.
Cool.
Thank you.
Yeah, you're welcome.
Actually, this might help everybody. As far as debugging on Eclipse, to look at those booleans and the other variables, because I remember in like engineering we were able to do, breakpoints and see the variables, you know, fluctuate.
Mm-hmm.
Is there a way to do that in Eclipse?
Yeah, there's a debug perspective. Um,
I tried that, but it's not showing me any of the variables. Like at one point it did, but it wouldn't increment anything, and then
yeah,
it
so
was.
let's play with that for a minute. And I don't know how well it works with swing because swing is event driven, and it kind of necessarily
It
um,
actually works really well.
with swing.
The thing, yeah, the thing
Okay.
I did was I opened up the source folder in Visual Studio Code and I used the debugger there. But you could also do the same like IntelliJ or Atom, which maybe if you're more used to those debugging environments where you can put in expressions and debug that way, you can also do it that way if you're not super comfortable with Eclipse.
Okay. Cool. Yeah, so I mean, you can go in and you can grab the source files and then use whatever your favorite environment is, for sure. Let's just take a look at this.
I actually use them in conjunction. So like the designer is so much nicer in Eclipse, so I just use the designer there, but I have the source folder opened up in another editor to do the debugging.
Okay. And this is the kind of thing that I've been talking about for 3 quarters, about like finding the environment that works for you. Find your set of tools that suits your particular style and get good with that. And it's very likely to be a mix of tools, which is good, right? As long as you have access to whatever the parts and pieces are. That's the ideal. So like when I do Arduino development, I use the Arduino IDE for compiling and uploading, but I use VI for editing, and I use something else for actually doing the upload part outside of Arduino. So I've got 3 different tool chains involved, and that's weird to try to figure out at first, but once you figure it out and you do it a few thousand times, it's like breathing. There's a lot of steps to it, but you don't really have to think about them anymore. um, so this is a total piece of junk code. With apparently really junky indenting too. All right. So I don't know what the heck this thing does. It's just code, and we can run it, and it's not going to produce any output. So under Window, you can say perspective and open perspective debug. And perspective is just the set of panels that you have here to work with your code and such. So I can. And I may have to turn off my VWrapper. And so let's see. So let's debug this.
One other really cool tool I did find in Eclipse is a debugging tool. It's called Coverage.
Okay.
And it will show you where in, it's like a profiler, and it will tell you what areas of code got covered and how much. And
Okay.
how long.
Nice. Yeah, profiling can be useful, especially if you got something you expect to be running a lot and it's never been run. It's a good way to track down flow control issues. Alright, so I'm in the breakpoints, and it looks like I can right click and I can say toggle breakpoint. So I can set a breakpoint right here, and I can set a breakpoint inside this if statement, and I can go ahead and say run, and I may have to run it as a yeah, I'm gonna have to do a debug instead of a run. And so it starts to execute and it gets to my breakpoint, right? And so I'm sitting right here, I'm about to execute y equals x times x. And if I come to variables, I can look at, for example, x. It's got a value of 0. I has got a value of 0. Y has not been assigned a value yet. So I can probably find a single step button, but I'm just going to go run and step. So F5. So now it's done this operation and it said y equal to x times x. And I can go ahead and tell it to continue running. And it'll hit a breakpoint when it gets back here. Now x is equal to 1, y is equal to 1. And where's my step button? There's my step. And so now y is equal to 1. It compares it to 5. And you can totally single step, and so on and so forth. And so if we ditch that, so I mean that's you know, C style debugging, basic stepping and looking at variables and putting on breakpoints. But if we go back to our Java perspective,
can you go to like? I mean, it really only runs the code once, right, for initializing variables. So you can't really, unless you put like a statement of, you know, this equals this, you know, specifically the boolean, to see when it switches over at you know, turns and whatnot.
mm-hmm.
There's not really a good place to put a breakpoint to check that, huh? Like, you can't put it in a method. You'd have to have a statement that says, you know, what is this boolean, and check that at that, or break it at that point, basically, right?
So I'm thinking that we can turn on watch points to say, for example, watch this boolean, and when it changes value, let me know.
And could you do that in the declaration of it?
Well, I'm wondering how to set that up here.
Okay, I'll let you figure it out.
I don't know for a fact that you can add watch points, but it seems plausible, and it should be a pretty straightforward thing to Google. But let me try one other thing first. Let's go into our panel constructor. Or let's go into save mouse, and let's just put a breakpoint right here. And let's go ahead and debug this. So run debug F11. And so there's my window. And I moved my mouse, right? And this was triggered on mouse motion, so I'm inside my mouse listener, which called save mouse loc. So for example, I can expand this, right? And this is whatever this thing is. It's a my panel, right? Which is an extension of a J panel, and so it has all of these properties. And I can look at each of these properties. I can look at foreground, and it's got, you know, these different components to it, and so on. So this variable window, you know, is much more than just is I equal to 0 or 1. You can go into objects and see the different fields of them, and so on and so forth, down to and including, you know, my X, Y that I've got stored here. And so last loc is a linked list, right? And I can expand that, and oh, it's an empty list right now. So let's step through this a bit. Let's add that point, and now if I look at last loc, it's got one entry, right? which is a point, and I can expand that point, and I can see the x and y coordinates, which was 482, 187. And so this is nice from the perspective of if you have complex classes and you want to understand what's going on in the different properties in an object, you could put in a bunch of print statements. But if you have 20 or 30 different properties, what do you print, right? So you can drill down into all of that in here, and you have to run it with a debug. F5. F8. All right. So I don't know about watch points.
Is there a debug console that you can just say watch X or so on and so
I
forth?
don't know if they give you command line access like that. That would be nice. You do a quick Google. Java debugging with Eclipse. A watch is a breakpoint set on a field. Oh, okay. So I can say watch. All right, so let's try that. Let's take off this breakpoint. Alright, so I've got a new variable here. Let's go into this. Let's find new variable. I'm making this up as we go, but that's okay. Alright, let's go ahead and run this. Let's move around. We get down here. So let's step it once.
So it definitely was a problem. Just so
Okay, cool.
I did get it back there for now.
Okay.
It was the bullying issue.
Cool. Well, now we're just about to figure out how to debug it, so.
Great.
A little backwards. But yeah, so you can right click on this and set a watch point. And so if we toggle the breakpoint, so there's no break, and then have it resume. Interesting. Oh, it is a different variable. Okay. Well, something like this. Play around with that. I can help you figure it out if anybody's interested in figuring out watch points or getting better with the debugger. But like I say, I don't think it plays terribly well with swing, because most likely you end up stopping in the middle of a event handler, and that kind of breaks things. But
see, maybe toggling in your reset method that it's player one's turn now. Good spot. Okay.
Yeah, cool. here. I honestly don't know what this is and why it won't die, but it's something I did. Alright. Well, that was arguably useful. But yeah, so there's a debugger. Print statements tend to work pretty well still. But if you're stuck, right, you can set up breakpoints. That works very well. And looking at objects works very well. I haven't done a lot of playing with watch points other than what you just saw. But I'm sure there's a way to make that work really well. And if you're interested in doing that, let me know. I'll dig into it and post a video.
Honestly, really makes me want something like a NOP statement in these higher level languages, because it would be really nice to just have like something that easily, quickly write and put a breakpoint on, like in MPLABX.
Mm-hmm.
End up being like a console system out.println or something, and then just putting breakpoint on that.
Mm-hmm. Well, I mean, you can make a no-op, right? You can just do like, integer nothing equals 0.
Or empty void. Yeah, that's a good point.
Or while false, All right. So yeah, since we were talking about PA4, so PA4 is graded. I've handed that back. PA4s look good. If you were not able to finish PA4, I gave you some feedback in some cases as to where I thought a change in direction might help. But definitely, come and catch me in office or ask questions here. Because PA4 is a critical part of PA5, right? PA5 is really a wrapper on top of 4, so if 4 is not working, then there's nothing to put the network layer on top of. So you want to get 4 to a place where you feel comfortable with it, and preferably sooner versus next week. So ask questions or come and find me in office to finish up PA4. But, majority of people were able to put up a field of dots. A number of people used linked lists, which you did not have to do, but that's an interesting way to only do those nested for loops once and just put the dots into a linked list. And then in your paint method, I saw a number of people just go through the linked list and just paint those dots, and that's a cool way to do that. So you can do that, or you could put nested for loops in your paint method. So most people got a field of dots up. Most people had some kind of reaction to mouse clicks, and the majority of people were able to draw lines between the dots that were clicked near. And then most of the point losses were either not noticing when a box was completed, or not putting initials in, or more minor details like giving a player an extra turn when they complete a box, things like that. So those were all relatively easy things to rectify. It's mostly a matter of understanding exactly what you're doing, what the kind of overall flow is in response to, say, a mouse click, and then being able to sort of put things in the right spot during that flow. But this, goes along with trying to sort of get a larger picture grasp of what your whole PA4 is about. And that will help with PA5, because PA5 is going to be, sort of doing some things in the middle of that program flow. So after starting up the program, all your PA4 does is wait for a mouse click, and then when a mouse click happens, it updates memory. That's really it, right? It's super simple description for, sometimes several hundred lines of code. But really, you just wait for a mouse click, you go into your listener, you find the XY coordinates, you do something. Now that something is a lot of algorithm, but ultimately, you find what line that corresponds to, you see if it's marked, if it's not, you update a variable in memory to say this is marked, and then some stuff is done with that. Maybe you call something that looks to see if a box is complete, you update a score, you see if the game's over. But it's really just response to mouse click, followed by, a bunch of stuff. And so in PA5, it's basically, response to mouse click, do a bunch of stuff, but at the end, send a message to the other player and say, hey, I clicked the mouse. Here's the XY coordinates. And the player who receives that will do exactly the same things that you did, except for sending the message at the end. So they'll update their booleans, and they'll check to see if boxes are completed and update scores and so on and so forth. So time spent, after this point, kind of polishing PA4 will be time well spent, because it'll help streamline PA5. The other thing I saw sometimes in PA4 was people painting from all kinds of different places. And there's this get graphics method you can use to get a graphics object, and then you can use that with like draw a line or draw a string from anywhere you want. That's possible, but you really, really don't want to do that. You really want to restrict all of your drawing to only happen inside Paint. And even though you can violate that protocol and trick Swing into painting from other places, number one, it's not just a bad habit, it's something that generally wouldn't be allowed in a larger project. Two, it's actually prohibited when you do things like, Android development. It will not let you do that. You'll get permission errors of some sort. Because painting needs to be controlled, right? You can't have all these different processes updating a display whenever they feel like it. You get screen tearing, and you get, ghosting of refresh rates and all kinds of weird stuff. And so you want to think about, how can I move all my painting, all of my drawstrings, all of my draw lines, all of my fill ovals into the single paint method. And this is this idea of sort of data-driven code where your mouse clicks just update data, typically an array of boxes which contain booleans, and then the paint method accesses that data to figure out what to draw where. And any time that you want to draw something else on the display, what do? You update the memory and you say repaint. And then the paint method clears the screen, reads that new version of memory, and does, all the painting. And it's a little counterintuitive, because if you have an array of dots and a bunch of lines and initials, and you click to draw one more line, the entire thing gets redrawn, right? Paint erases the screen, that's what the super paint does, and then it goes through all 64, boxes and draws each line and all the dots and so on and so forth. And that feels kind of that's not how we play dots. We don't, erase the page and redraw the playing field with an extra line. But the display of a computer is not like a piece of paper, right? It's something that's constantly being erased and refreshed, right? 30, 60, 90 times a second. So this is, kind of in harmony with what's going on at the hardware level.
I found myself writing a lot of my code like you would in jQuery with JavaScript, or with Godot, where you would get sibling nodes, and then every time you update their data from other classes, you call methods on them, just make sure to repaint it after you're done.
Right. And that is pretty much how all these systems work right now. That may change in 5 years as things evolve, but right now, most sort of more complex systems that you'll work with, games, smartphones, anything that's doing graphics on a laptop or a tablet, right? Generally, your painting happens in one location, and everything is responsible for setting things up so that when that paint code runs, it paints whatever you want painted, right? Rather than just randomly calling, draw a line, fill an oval, when you happen to want that.
It's actually a new paradigm that's kind of changing that
Mm-hmm.
entity component in Rust,
Mm-hmm.
where you can actually kind of multi-thread your drawing.
Oh,
And
cool.
execution of like child nodes in a scene tree.
Okay, cool. Yeah, so I guess we've got more processing power now. and our GPUs have lots of cores, so we don't have to have sort of one centralized paintbrush. So that's cool.
It's pretty complicated. I can't understand it at all.
I can imagine though what it's doing basically. Right? I mean, you could have multiple things updating the display as long as they're coordinated with one another. And you know, a typical GPU, you've got enough horsepower and enough independent cores to make that coordination believable.
It's interesting to think of it like atomic processes, but the object they're trying to protect to not step over is like the screen buffer.
Yeah, yeah. And this kind of falls in the broader category of, you know, what's the best programming language to learn if you want to get a job? Well, there's no good answer for that. You know, you can find lots of analysis of which languages are hot when and what's changed and predictions about what's going to be hot in 2 years or 5 years. But that's really not the point, right? You might get lucky and learn, you know, Fuselbar 2.0, and that ends up being the really great language when you enter the job market. But, you know, your better option is get really good at learning languages, right? So you've done a lot of C, you're learning Java now. We might, you know, talk briefly about C++ the last class or something. You'll definitely learn Python at a university. And the more languages you learn, the more you sort of like build the pathways in your brain that allow you to learn a new language, right? Spoken languages like this. Learning English is horribly complex. Well, it's a horrible language to learn anyway. But, you know, your first language is really complex, and then if you learn another language like French, you know, or a Romance language, that takes a lot of work. But after you've learned, you know, 5 or 6 languages, you start to figure out tricks to learning languages, and it becomes easier. And so the more you can expose yourself to different kinds of environments, right? If you can do Unity and you can do Unreal, while you go to some other game engine, it's not going to take you nearly as long to figure it out. Whereas if, you know, you go from nothing to trying to learn Unreal, it's going to be, you know, strong coffee and hair loss.
It's a bit unreal.
Yeah, it is.
I can't remember a damn thing about it. It's so complex.
I can spell it.
Unreal, I was going to make my game in Unreal for my SLP.
Yeah.
I downloaded Unity and Unreal, and I went through like the steps, and I was like, dude, I am beginning, and Unreal is just ridiculous.
Yeah.
Unity was very easy, but the overall product at the end is not quite as good. But,
Right.
You know, the thing I found the most interesting about it is like if you coded in a lot of other things that are more object oriented, you'll see that it starts to mix the paradigms itself. Like Godot and Swing and jQuery to an extent, those are all like inheritance.
Mm-hmm.
And Unity is more of a compositional approach, and Unreal is actually both, with like 2 different base classes.
Mm-hmm.
It's got like an actor base class,
Right.
component base class.
We're getting some PTSD over
Yes,
here.
The graphics and the setup of the game, and I mean, you still have to know the coding too, but it's pretty ridiculous.
Mm-hmm. Yeah, just walk around a room and say blueprints and see who cringes and.
Oh yeah, that's where I was like, nope.
Yeah.
I thought those were cool. That's like also the best part about it.
Yeah. All right. So let's talk some more about this whole client server business. I want to talk about sort of the networking aspects that we began on Thursday, and dig more into what this looks like. Look at a little bit of where this came from. Talk a little bit about some of these other things like network addresses and routers and things like that. But I want to start with some code, right? I want to get some code together in Java that you can actually use for PA5 and for, you know, general life skills. So let's do Java code for servers. So we started playing with server sockets, so I'm going to keep going with that. So this is going to come from java.net.server socket. And we're also going to need sockets. So I'm going to go ahead and import Java net socket. And let's just write some sample code to play with, and we'll use Telnet as our client for now, and then probably Tuesday or Thursday we'll go ahead and we'll write the client side of things. But let's just play with the server for now. So create a socket. So create a server socket to allow clients to connect to us. So there's my object, SS, that's a server socket. And I'm going to have to do the construction in a try-catch block. Because constructing a server socket has lots of potential for errors. So the constructor, turn on total cookie protection. Not now. So the server socket can throw an IO exception, a security exception, an illegal argument exception, right? So we're going to have to catch all of those, and we'll just use the sloppy, you know, catch everything. So we'll create a listener on port 1234. And then we're also going to want to, once we have that server socket, we're going to want to listen for connections. So we're going to use this method called accept. And accept can throw an IO exception, for example, if the connection closes, or a security exception, or a timeout exception, and so on. So we're gonna go ahead and put that in the same try-catch block. So this construction creates the server socket, and the accept call waits for a connection request. So the picture might be like this. Here's port 1, 2, 3, 4. And a socket is just, you know, a round purple circle that you can connect to another round purple circle. And so here's the socket that we create, the server socket. And somewhere a client is going to create its own socket and say, hey, I want to connect to port 1, 2, 3, 4, this socket. So this call to the constructor creates this socket, and after that's created, if somebody tries to connect to it, then this call to accept will return. And until somebody tries to connect to it, that call will block. So the accept method says this method blocks until a connection is made. So let's throw some print messages in here. So our first message will be creating server socket, and our message will be waiting for a connection. And then once we come back from accept, we'll say connection received. And if we get any exception anywhere in there, we're just going to print a message and return. All right. So that's our first setup. Now this accept method, it returns an object of type socket, and it says that a new socket S is created. And if there's a security manager's check accept method is called, blah, blah, blah. All right. So what happens when I say accept? I've got the server socket. I'm willing to receive connection requests, right? If somebody tries to connect to me, the accept method creates a new socket and connects that to the socket that requested the connection. And now we have this two-way conduit between some new socket on, the host machine and the socket on the client machine. So I can call this a server. So server creates a socket to listen for connection requests. Client requests a connection. Server calls the accept method. When it returns, it gives us a new socket, and that socket is connected to the client socket. And now we have a two-way conduit for sharing information with the client. And this server socket is still available for another client to come along and say, hey, I want to make a connection. If the accept method is called on this server socket again, a new socket is created, and that creates another two-way conduit for communicating between the server and that client. So we're going to take the accept method and we're going to return an object. I'm going to call it client socket. So I'm going to declare this up here. I'm going to call this a client socket. I'm not going to call it client socket. What's a good way to describe this? I mean, it's the socket connected to client.
You could probably call it the client socket, and then the thing that's kind of weird is you named the class server, so it could be either a client or a server.
Yeah, and client socket is fine for now, but when we start writing the client side code, that's going to be the client socket. So I'll be long and wordy and say socket connected to client, right? Because that's pretty unambiguous. We're talking about this thing right here, right? On the server side, but it's the socket that gets connected to the client. And let's just go ahead and print that out. So outside of our try catch, we can do other stuff. Let's do this. Connection received. Return value equals, and let's do socket connected to client. All right, let's just leave it at there for now. And let's open a new window. And I'm going to use telnet as our client. So I can say telnet localhost 1234. And normally if I do this, it immediately comes back and says connection refused. So this machine called localhost, which is, the same machine I'm running telnet on, told me there's no socket with a port number of 1234 that's willing to accept a connection right now. That's the sense in which it was refused. So if we run our Java code Now it says, you know, it created a server socket that's waiting for a connection. So this code is sitting inside this call to accept. Right? We're inside this accept method. And it's doing something, you know, waiting for a connection request. So now I can do that same telnet command, and a few things happen. Right? I come back from the accept request. I've got this socket connected to client, and that's equal to, well, this is what the toString method returns. And it's telling me, hey, there's a connection coming in from this address, that's this machine, that's what localhost is, 127.0.0.1. The port number of the socket that connected to us is 44586, so that's the port number of this socket. And the local port number that was connected to is, guess what, 1234. Right, because that's the address we bound to the server socket. And then, you know, we fell off the end of the earth, and when our Java program exited, those sockets got closed, and so our telnet client said, foreign host, closed the connection, and it exited. Alright, so let's send some data to the client. Once we have a connection, let's have the server send a message to the client through this socket pair. And so we can do this with print writers. And so let me go ahead and declare a print writer. And I'm going to call this toClient. And that's for sending to the client. And we're going to have to do an import. So this will be java.io.printWriter. And this can also fail, so I'm going against my edict when we learned about try-catches, about making your try-catch blocks as small as possible. Theoretically, each of these could go in its own try-catch block, right, except and so on. But I'm not worried about it right now. If anything goes wrong, I'm not expecting anything to go wrong. So if anything goes wrong, I'm just going to go ahead and print out what the exception is. Let's print that out here. But I want to get through this by the end of class, so I'm going to be sloppy. Open the print writer for sending to the client. So what's our print writer called? toClient. And we've got to construct a print writer. So if we look at the documentation on a print writer, check out the constructors. We've constructed with system.out. Well, we didn't actually construct that. We've constructed with a file, right? So we created a new file that itself was constructed from a file name, and then we passed that file object to the print writer. We also have the option of constructing a print writer on what's called an output stream. And an output stream is something like system.out, right? It's a pre-existing conduit for transfer of information in the output direction. So it turns out that the socket class has a method called getOutputStream. And getOutputStream gives you an object of type outputStream corresponding to the socket. So it will give you an output stream that lets you send information from from this side to that side, right, to the client socket. And this can throw an exception, so that's why I'm putting all of this inside the try-catch. This can throw an exception of an I/O exception, and this can happen most typically if, you know, by the time you get around to trying to construct the print writer, maybe the connection has closed. maybe the client has exited the connection and this conduit is no longer available. So it might throw an exception. So how do we get the output stream? We use the socket name. So socket connected to client dot get output stream. And that's a method, so we put parentheses after it, right? Super duper use of objects here, right? We have a socket connected to client, that's an object of type socket. We call the get output stream method. All of this is an output stream. We use that as a constructor to the print writer. The return from this is a print writer named toClient, which is used to send information through that socket to the client, right? That's an amazing amount of stuff happening in one line. When you write this in C next year, this is going to be more than one line. So this is where Java or, you know, object-oriented languages in general are nice, because all of the stuff that you're going to have to eventually do to do this in C, this is in a future class, all of the stuff you have to do is embedded inside, you know, this method and this method and so on and so forth. So we just do this, a one-liner, and now we've got a print writer which we can use to send information to the client, presumably. So let's send a message to the client. There we go. So we'll go ahead, we'll run Java main, we'll go ahead and we'll do our telnet, and we connected and we got our message over here and we got our message over here, but we did not get that hello client message, right? This is a decision point, right? Do you delete your code and start over? Do you go to Stack Overflow? Or do you do something else? Okay, well, I'll save you all those headaches. I'll tell you what to do here. And then the next time this happens, you've got to either delete all your code or go to Stack Overflow or go back to your notes. Most I/O that we're doing with things like print writers, this is high-level I/O. This is meant to, you know, display something on a screen for a user. It's low speed, it's human readable usually, and most things in those categories are buffered, right? And so buffering is something you definitely need to keep in mind. Buffered I/O. And we've talked about this a little bit with files, and it was kind of an interesting thing to see. With sockets, it becomes super critical. And the reality is that when I say print line, note that this does not actually get set here. The print line method takes those characters for hello client and it puts them in a buffer, a pipeline. And it says, hey, we've got this message to deliver at some point, right? So imagine that you're using pigeons to send messages, right? CSE223B pigeonhole principle, flashback. You're using pigeons to send messages, right? And somebody is dictating a message. They tell you the first word of the message. Do you take that and put it on a piece of paper, tie it to the foot of the pigeon and send it off? And then wait for the second word, right? That would be really, really inefficient. Because using a carrier pigeon is a very low bandwidth means of communicating. It doesn't allow a lot of transmission. There's a lot of overhead. And so what you would probably do is you would wait until you got the entire message, and then you would write that on a piece of paper, attach it to the leg of the pigeon, and send it on its way. Or alternatively, if the person was dictating War and Peace, you would get, the first 100 words, put that on a piece of paper, attach it to a pigeon, send it off, and then get the next 100 words, attach that to a pigeon, and send it off. So if we do enough print lines and we put enough information into this buffer, eventually it'll get flushed, because it'll get so full, it'll say, okay, you didn't tell me to flush this, I'm going to flush this anyway, because it's gotten too big. So what we want to do is we want to say, hey, I want you to take this message as I've given it to you right now and flush it out. So we say toClient.flush. And that takes the output that is buffered, the stuff we typed up here, and it actually forces it to be sent. And this is a really, you know, minor thing in terms of amount of code, but it's one of these things that if you forget to do that, it can drive you nuts. Because there's so many things that can go wrong with doing networking, and what's going wrong might actually just be you didn't call the flush method, right? So your best option for debugging is to avoid bugs, right? So here's a bug. If you can avoid it, that's good. So let's go ahead and compile this and run it, and then we'll do our telnet once more. And now, after we made the connection, we got a message back from our Java program that said, "Hello, client." So this is success, right? This is a set of Java code sending a message through a network to another program. And this program, Telnet, I happen to be running on the same machine as this Java code, but it could have been a different machine. I could do this on a different laptop, and it would still transmit the message. How big a message is socket going to send? When is it done receiving data? So
I was just saying that's like part of.
oh, part of dealing with
Yeah.
yeah, exactly. And so for a lot of this, we can sort of leave those decisions to, you know, the system. We can just use buffered output and so on and so forth. But once in a while, we need to at least, you know, do a flush or something. Now, if we're doing a high performance system, then, you know, we're going to start wanting to take more control over this. We're going to want to have, you know, packet sizes and things like that. But we're probably not going to be using print writers for that, right? There's lots of different ways to do I/O in Java, and there's lots of different levels of I/O, and this is the one that's sort of, you know, minimal overhead to us, right? It's a one-line constructor and a one-line method to print something and an occasional flush. But there's, you know, this is a super simplified view of a much broader topic. All right, so we can send messages. And, you know, I could do something like, you know, I can put this in a for loop. And I can send this message 10 times with an integer after each time, right? And then flush this at the end. So I can compile that and run it. And now if I do my telnet connection, I get a slightly more dramatic demonstration that I'm actually sending messages from this Java program. And, you know, this is print line. If I just do print instead of print line, right, then my messages come out side by side because there's no new line. So there's really no magic here, right? All the stuff that you do already with system.out.print or print line, right, we can do. We're concatenating an integer to a string, and there's a toString method being called, and so on and so forth. And all of that is you know, business as usual, with the one notable exception that this is, you know, not printing to standard out, it's printing into this pipeline, and it's actually going through, you know, some sort of conduit to another program. So that's how we can send output. How can we read input? So if we want to be able to ingest something from the client, we can use a scanner. So let's make a scanner called FromClient. And we'll import Java UL scanner. And so let's construct our scanner down here. I should say create. So the scanner class, we've constructed that on system.in, and we've constructed it from a file. Well, when we construct it from system.in, system.in is an input stream. It's just another type of object. And sockets also have a method called getInputStream. And so we can construct a new scanner from socket connected to client.getInputStream. And that can also throw an exception. So, got a big long try-catch block. I'm going to lose a bunch of points if my professor sees this. That's okay. And so let's...
Are we going to lose a bunch of points if our professor sees it?
Nah, you should be okay.
Okay.
So, yeah, because so the reason it's okay is because, you know, other than the print statements, right? Really, every statement I have in here is one that could potentially throw an exception. And the only difference, if I decided not to put these all, is I would say, you know, try this, catch an exception. 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 And it's really just making more code. Unless I'm doing something very particular with, you know, the different exceptions, which I'm not here, right? I'm just gonna basically throw up and exit. It makes no sense to put them in different blocks. But if my entire PA5 is sitting inside one try-catch block, that's going to be a problem, right? So I'm putting it around the statements that can throw the exception, and leaving it at that.
And I'm assuming, because I'm vaguely remembering from Thursday, you were showing us how it's going to interface.
Mm-hmm.
It's supposed to, there's going to be like a text input, right, where you can put the user who you're playing against IP.
Mm-hmm.
Right?
Right.
So you're going to, instead of 1, 2, 3, 4, you're going to make that a declaration for a variable and use the variable in there.
Well, we'll expand on this in a minute after a break, but the 1, 2, 3, 4 is what we call a port number. And it's part of an address. There's actually two parts to an address. There's an IP address, which is something dot something dot something dot something, and then there's a port number, which is a 16-bit number. And so this is 192.168.0.101. That's the machine, and this is the ID of the socket on the machine. So this is the part that the client wants to be able to specify, to say, hey, I want to run against the client sitting on the Linux server, or on my friend's machine whose IP address is such and such. And the 1, 2, 3, 4 is going to be hardwired in the code.
Okay, gotcha.
And yes, IPv6 changes all of that. And it gets kind of crazy.
That's like a hexadecimal number, isn't it? IPv6.
They can each be either hex or decimal. That's the representation of it. But the number of bits for each field of an IPv6 is more than just 8 bits, I believe. And so here with IPv4, each of these is an 8-bit number, and so the whole address is only 32 bits, and that's why we ran out of address space, right? Because that's only 4 billion unique addresses, and there's way more than that number of internet connected devices in existence right now.
I never thought about that. The DNS is 255, 255. That's just because that's the highest number, basically.
Yeah, it's a bunch of ones.
Huh. Okay.
I heard somebody put it this way once, and it stuck with me ever since.
Yeah.
That you can only have about 4 billion IPv4s, but you can have about the same number of atoms in our atmosphere of IPv6s.
Ah, nice. That's good. So until we have internet-enabled atoms, we're okay.
But
I hear it's in production.
Yeah. It'll be called iAtoms if Apple does it first, and just Atoms if it's Windows. All right, so let's read a message from the client. So I'm going to do string so I'm going to say while and this is from client dot has next line. All right, so here's a loop to read and send message. So while from client dot has next line, let's read a message from the client. So message equals from client dot next line. This is the message, and let's send the message back to the client. So for I equals 0, I less than 10, I plus plus, instead of saying hello client, let's do hello client plus I plus plus message. And so we'll do that 10 times and we'll flush the buffer, and then we'll go back and we'll wait for a new message. And then at the end of this, we'll just print out a message for ourselves. And we'll just say leaving while loop, goodbye.
Your read a message has a slash and a dot.
It does. Thank you. All right, so let's compile that. Yeah, something went wonky on there. How about string message? All right. So let's run this, and we're waiting for a connection from a client. So we're going to go ahead and do our telnet, and it says, connection received from this address, this port number, and over here is our telnet client. So if we run our netstat command to look at active connections right now, we should find port 1234. So there's port 1234. That's the server socket that's listening for a connection. Here's the connection between port 44706 and port 1234. And it's an established connection, so it's been hooked up, and it's a two-way connection, right? And if I exit my program, this will change from established to close wait, and eventually it'll go away. So this is a connection that's in place, and telnet, it's a client program, lets me type some stuff, hit enter, that gets sent to, in this case, localhost port 1234, and anything coming in from that connection will get printed on here. So if I say this is Nick, I get back 10 messages saying hello client, there's the number, and it says this is Nick. So we've got, a little bigger set of Java code, but still not too much. But the main action is, right, read a line from the user and then send it back. And we're just reading using a scanner, and we're writing using a print writer. So it's not fundamentally different from the stuff we've been doing in the earlier assignments, right? It's the same classes for input and output. We just constructed them differently. But when we want to write, we do a print line. When we want to read, we say, you know, has next line and next line. All right, and telnet, when you connect, it says escape character is, and it says, you know, caret right bracket. That's a shortcut for control right bracket. So if I hold down the control key and I hit the right bracket, it brings me back to a prompt. And normally, you know, everything that I type is being sent by the telnet program. So now I'm at a prompt, and I can do things like, you know, ask for help messages and so on and so forth. So one thing I can do is I can say close, which says close the current connection. And when I do this, my Java program should notice that the connection has closed, and it says leaving while loop goodbye, and it exits. So we've got the ability to do, you know, communication through sockets from Java without a whole lot of overhead. All right, so let's take a 5-minute break, and then I want to talk a little bit about what's going on under the hood here, as far as addressing and TCP/IP and what that's about, and I want to talk a little bit about routers with respect to this. And then I definitely want to look at radio buttons and Eclipse before we leave today, just so that we get that part taken care of. It's like a 3-minute exposition to do radio buttons. So let's go ahead and take a short break, and we'll come back at 5 minutes 18 seconds, and I'll see you back in here then. Alright, my potatoes are growing.
How to manage that far in between breaks, huh?
Yeah, exactly.
Awesome.
I'm shocked how laggy it is though while I'm running this other stuff. So I don't know if it's Zoom or my my screen recorder or what, but it's like super pokey.
It could be something about Zoom because I actually finally fielded yesterday with Mint, and for some reason Vulkan doesn't like it when you stream things at the same time as playing the game.
Oh, interesting.
So even through compatibility layers like
Mm-hmm.
Proton.
All right.
You said you're out in East Vancouver, right?
Correct.
Terrible.
Is it? I haven't had bad luck.
We have,
I mean, I'm on Comcast and I can upload, my videos are usually about 2-something gig. And they upload in about, 25, 30 minutes, which is better than I'm used to.
yeah, we have
Pretty good
one
out here.
We have one DSL line for CenturyLink. That's all we got.
Oh. Yeah, that's dedicated bandwidth though, right? Theoretically.
Yeah, well.
Unless it's
at 3
down.
in the morning, we get like 5 megabytes
Ah.
down, which is just terrible.
What's crazy is Clark, their internet has always been like kind of slow and stuff, but their upload speeds are blinding. It's like I can take a 2 gigabyte video and upload it in like a couple of minutes sometimes. It's absolutely crazy. I used to like save all my uploads and do them there. All right, so little bit about addressing and IP addresses and TCP/IP and all this kind of stuff. This is not stuff that affects our ability to do PA5. Really, to do PA5, we need to know how to make a server socket, and we need to know how to make this client socket, which is just called a socket. And we'll go through that on Thursday. But it's really just another type of object. We construct it with the address and port number we want, and then construct a print writer or a scanner using the get output stream, get input stream methods, and it works almost exactly like a server socket. But it's useful sometimes to sort of keep in mind what's actually going on beneath all of that. And so I just wanted to touch on that a little bit because we throw around a lot of terms like IP address and port number and client server and so on. So I wanted to add just a little bit of substance to that. So, theoretically, our network, is a bunch of machines, and they're connected together through some combination of links, right? Which might be, physical wires, or they might be wireless connections, or fiber optic, or something buried under the ground, or something running across the ocean, or, something. And the first thing you need to do is you need to be able to identify a machine. So if this machine wants to send a message to this one, it has to have some way of addressing this. And the way this was originally done was to use what's called an IP address. And IP addresses are 4 bytes. So 4 numbers, each number is 8 bits. So it's something from 0 to 255 decimal. And 77.18.4.11. That might be someone's IP address. And it corresponds to a particular machine. And theoretically, any machine on here that tries to send a message to that address, that message will eventually find its way to that machine. And so one part of this whole network business is just getting a message from one point to another, from machine to machine. So we use these IP addresses. And when I first got into this, which was mid 80s, we had 2 types of IP addresses: 10 point something point something point something, 26 point something point something point something, and that was it. And each of these was sort of its own separate network. This was a network of schools, universities, research labs that was called ARPANET. this was a network of, Pentagon headquarters and Army barracks and so on and so forth. This was called Milnet, right? And this was the military version of the network. This was the civilian version. And that was it. This first piece of the 4-bit address identified which network you were on. And generally, if you tried anything other than 10 or 26, there was no such address. And so you can try to divide your address space, and maybe you could say, okay, this will say what part of the world this is in, or what part of the country this is in, or something. But more often today, right? This is just a 32-bit number, and stuff is so mixed up together. We don't have a whole lot of super precious first pieces of IP addresses, but there's a set of addresses you see often, which is 192, and often it's 192.168, and a lot of times it's 0.0 point something. And so this is where routers come in, right? If every machine on the network had its own 32-bit address, we would have run out of addresses a long time ago, right? Just think how many different machines at Clark College are connected to the internet. And every time you turn on a phone, every time you turn on a Kindle, every time you connect your fitness tracker watch to the network to upload your latest run, right? If every one of those devices had a unique IP address, we would have run out of space a long time ago. So a lot of these machines have connected to them a sort of mini network through something called a router. And so this whole thing is the internet, right? Inter, between, and the router basically controls an intranet. So intra, within. And the router setup, I know a lot of people know this already, but some people may not, so I think it's worth a few minutes. You have a router, and you have a series of machines, perhaps in your home connected to this. So a couple of laptops, a TV, a printer, a phone, maybe a few phones. And each of these things has a network address. So this might be to 192.168.0.101. This might be 0.102, this might be 0.37, 0.111, and so on and so forth. And these are not addresses that one of these machines can use to access your printer or your laptop, right? These are addresses inside this little subnetwork. And when my laptop wants to send something to the printer, it says, hey, I have a message for, 192.168.0.111. It sends that to the router, and the router says, oh, okay, I'm going to pass that out, this cable connection to this Cat5 cable that's connected to my printer. The way these go together is, I have some machine, a router with, an actual address on the internet. It's a fictitious address, 77.68.1.47. And that's the address that somebody else can use to access, but they use it to access my router. So now if my laptop 2 wants to talk to Google, I tell my router, hey, I want to send a message to, whatever Google's IP address is, and my router, which is on the internet, it's one of these machines, can send my message to, whatever router is associated with Google. And if I'm initiating a message, my routing information goes along as part of that message, and whoever I'm sending it to, they can get back and respond to me. But if Joe Hacker is sitting on a machine and says, oh, I'm going to hack Nick's laptop too, right? They don't have a way to get a message to this machine. They can talk to this address, and they're just talking to the router. But if my router is set up correctly, it's not going to take any information that's coming into it and send that to my laptop. So this is why a router functions as a firewall. It basically prevents, the flames that are out here in the wild wilderness from getting to my machines on this side of the firewall. The exception, or one of the exceptions, is if I want somebody to be able to access me. So I'm running my NetDots game on laptop 2, which means I have something sitting at this IP address at port 1234 waiting for a connection. Somebody talk to me, right? So what I can do is I can tell my router, hey, if somebody connects to you at this address and asks for port 1234, forward those packets to whatever the address of laptop 2 is. And so you can set up this port forwarding. And now, Joe Hacker out here on the other side of the planet can access my router with this IP address, ask for port 1234, connect to that port, and now they can play dots with me. So you can set up port forwarding in a router. You don't want to do it unless you're really confident that you have a reason to do it and you know what you're doing, because it does basically put your machine on the internet, right? The big network, which means that theoretically anybody, anywhere, can make a connection to any socket that's listening for connections and can send anything they want to it. And now it's up to the security of your software to make sure that what they send does not cause a problem.
I was going to ask if you could go over how you could actually set that up yourself. Like, for a long time, I've been using things like virtual private network servers like Hamachi to play older video games over LAN through a VPN like that. But I don't actually know what the code for that looks like, how you would go about setting up port forwarding or something like that. Do you think maybe you could go over that at some point?
Well, most routers, if you just go into the router itself, so usually 192, so this router also has an address on the intranet, and depending on the manufacturer, it's usually 192.168.0.1 or maybe 0.2 or maybe 1.1. And you can Google, you're usually just the brand of router, not even the model number, will tell you what that address is. And so you go into a web browser. I guess I can do this without exposing my network. 192.168.0.1, and it takes me to my router's login page. And so you want to have a good password on your router. Never ever use the default password. And past few years routers ship with a bizarre password, but they used to ship with a password like router or default. And I heard a talk from a head of security at Virginia Tech a number of years ago, and he just went around town. I think he rode the bus and he tried to access people's routers using the default password. And something like 80% of the routers on the bus line hadn't changed their password. And if you can get into somebody's router, you can do all this stuff like set up port forwarding and track network connections and all sorts of stuff. So you definitely want to make sure you have a good password, which I'm not going to type in here. But once you do that, depending on the brand of router, you'll get to some sort of setup page. And there's usually an option in there for setting up port forwarding. And it lets you do a number of things, like say, I only want to forward requests from this particular set of addresses. Or maybe I only want to forward during certain times of day. So if you're running like a Minecraft server on one of these machines, you need to have requests to a certain port. I can never remember the port number, 14,000 something. You need to have requests to connect to that port forward to your server. And maybe you only want it on certain times a day. Maybe there's people who have come in and messed with your server, and so you can put them on a do not accept list, right? And you can do this in software also on the server software itself, depending on how it's written. So there's a lot of responsibility on what's going on this machine once you give the outside world access to it. And if this is a C program, which has a character array of 256 characters, and says create a server socket, accept a connection, read a message, right, into this buffer. If you don't write your code well, you can have things like buffer overrun possibilities, right? If you somehow used gets instead of fgets, and somebody sent you a message with 1,000,000 bytes, and your buffer that you're loading those bytes into can only hold 256 bytes, that message is going to start overwriting other things in memory. And if somebody knows what they're doing, they can use that to manipulate the machine that they're connected to. So generally, if you take a machine, you just put it on the network, it is pummeled with exploit attempts. Like a few seconds after you connect it, it's just this non-stop stream of incoming traffic, sniffing for open ports, trying to send things into open ports, trying to use default username passwords from different lists to log in through a secure shell server, and it's crazy, right? So people usually keep their machines behind firewalls, and they let traffic through very, very selectively.
I read the other day that there was a mathematical study on C and C++ programming languages and how they deal with memory, and it's mathematically impossible to avoid those buffer overruns.
Yeah.
Cannot actually secure them. And that's one of the interesting things about Rust these days in its ownership system, is it kind of prevents things like that from happening.
Yeah, and that's part of the idea of Java, was to try to kind of get rid of pointers in a way that is supposed to make it harder to have these buffer overruns, and to have a sandboxed model and have it running on a virtual machine and so on. It's very hard to do well. I think if I write a hello world program and put it on the net, it's probably safe. But people have found hardware issues inside the CPU that are exploitable, and it's a kind of never-ending game of measure countermeasure, and the ability to find new exploits is staggering. You start looking at things like power grid exploits, where you can plug something into an outlet in the same building that a server is running, and by monitoring fluctuations in the way the signal looks coming out, the 60 hertz power line signal, by monitoring fluctuations in that, you can try to log into a server, and you can actually tell how close you are on the password by how the power line fluctuates. This was a study that came out several years ago. I think it came from Israel, and it was just insane. It's like, but everything affects everything. Everything leaves a fingerprint somewhere, and just power line modulations gives you enough information to do some pretty intelligent cracking of some password schemes. So it's pretty insane.
It makes sense with like power line Ethernet, even if there isn't a network connected to the power line, you can still read it.
Yeah, totally.
Nuts.
And nothing is secure physically, right? All the stuff that we send on a Wi-Fi network, anybody with a receiver can pick that up. We're really just banking on the encryption to protect the contents of the messages, the actual information in there. But the medium itself is totally, exposed to whoever. Oh yeah, and just like keyboard sniffers are pretty basic and really hard to avoid. You go into a cafe and keyboard plugs into the back of the computer, and you just throw a little dongle in there that picks up keystrokes and sends them, periodically to an IP address, and you can see what people are typing. And it's pretty easy to figure out when someone's typing a username and a password.
I always wanted to get like one of those key input automatic, I forget what they're called, but like they look like a USB drive. You can write them like an Arduino and have them send keystrokes.
Oh yeah.
Just for fun.
Mm-hmm. Yeah, totally. All right. So the other piece of this, I just wanted to mention. I went into more detail on this yesterday, and so I may not go into as much detail today. But you can look at yesterday's video if you want to see this at a deeper level. But underneath all of this, there's the question of how does this stuff actually get sent. When I say this machine sends a message to this machine, right? How does that actually work? If you actually were to get down to the lowest level of it, and so we talk about TCP/IP, and TCP/IP are a pair of protocols that describe how messages can be sent in a network. And here's a picture you see a lot, the 7-layer representation of a network. And the idea here is there's a hierarchy, right? So the application level, if we look at the simpler model here, the 4-layer model, the application level is, you know, your NetDocs program. That would sit up here in level 4. That's the code that says, hey, open a server socket, wait for a connection, read the name, send a name, that kind of stuff, right? For that to do its stuff, it needs to somehow send information to another machine. So that's handled by the transport layer. That's the thing that actually sends the information from one point to another. And then there's the question of, you know, how do you get from that location, you know, from that machine to a particular this is the application layer. This is saying, you know, port 1 2 3 4. This is saying get to this machine, get to that machine. And this is the physical stuff. This is the Ethernet cable. This is the Cat5 cable. This is the round coax cable or the radio transmitter in your Wi-Fi router, and so on and so forth, right? And your Java program does not contain code to run the RF transmitter in your router, right? It does not contain code that takes the signal received by the RF router and does the Fourier transforms on it and so on and figures out what message is coming in. It does not do the code that handles the encryption when you have your router connected through, you know, a secure connection, right? This is handled by the network layer and the internet layer. And the internet layer does not do things like say, oh, this person clicked their mouse at 10,20, let's draw a line, right? So the application layer interacts with the transport layer. The transport layer interacts with the layer above it and below it. The internet layer interacts with the layers above and below it. And so this hierarchy is a way to sort of partition the different levels of operations that have to take place to do a networked communication. And this means that, you know, if I take my Wi-Fi router and I plug a cable into it and hook that into the cable port on my laptop, I'm using a totally different physical layer now. I don't have to recompile my code, right? That would be horrible. So changes down here are hidden from, you know, the pieces that are running at these higher levels. And if I decide that I want to change NetDots so that it can, you know, use 3 players instead of 2, I don't have to recompile my Ethernet driver in my Linux kernel, right? These are totally separate from each other. And that separation and standardization is part of why things like the internet can exist. Because as long as everybody understands how to talk to the transport layer, you can do whatever you want up here. And as long as the physical layer understands how to talk to the internet layer, right, you can do whatever you want down here. You can make this wireless, you can make it optical, you can use coax, you can use Cat5, you can use smoke signals, right? You can do serial line internet protocol and run this over a phone. And the hierarchy, you know, sort of ensures that there's insulation from one layer to another. So it's worth just kind of for kicks looking at some of the original documents on this. So an RFC is a request for comment, and so let's see. 40 some years ago, there was RFC 793. And RFC 793 is a request for comment on something called Transmission Control Protocol. So this is TCP. And this was, being developed by DARPA, so this was Defense Advanced Research Projects Agency. And you can, read all about this. It's basically, what is this talking about? What's the philosophy of connecting systems together? Internetworking. We don't call this an internetwork anymore, but that's a cool term. You could pretend you were like, I don't know. And so there's lots of information in here, but I want to just kind of cut down to a few pieces of it. So there's the 4-layer model, right? Higher level, whatever that is. TCP, which is this document. Internet Protocol, which is a separate machine-to-machine communication, and then the sort of physical stuff at the bottom. And if you go down here a little bit, you can find some awesome ASCII art. There's a different view of the levels with, particulars, telnet for interactive sessions, file transfer protocol, voice, and so on and so forth. I think they put voice in because they were optimistic, but they had no idea how prevalent that was going to be.
Is this, do you have this posted on Canvas, maybe?
I don't, but if you Google RFC 793, you'll find lots of copies of it.
Gotcha.
So this is what a TCP packet looks like. So 32 bits on each line, 4 bytes. The first 16 bits are the source port. That's the port number this message is coming from. Next is the destination port. You can send your message in pieces, and so you can put in a sequence number, because since this is, a multi-machine protocol, if I send 5 messages, 1, 2, 3, 4, 5, they might not arrive in the same order. It might be that message 2 hits a machine that's very slow, and message 3 takes a different route and gets to the destination first. So we can sequence our message pieces, and we can acknowledge them, and we can have checksums to make sure the message we received is the same that was sent, and so on. And then after the header, we add some data. And this is the ones and zeros that are sent either through a wireless connection or a cable or something to convey a message. And the data that we send is something described by RFC 791. So that's the Internet Protocol. And this is a different header that looks like this. So it's got a version and some flags and so on and so forth. But down here, a source address and a destination address. Where is this packet going? Where is it coming from? These are the 32-bit addresses that we call IPv4, Internet Protocol version 4. And so these go together. You use a TCP packet and use an IP packet and put them together with your data, and you throw it out on the network. And as machines receive these, they can either dispatch them to a server on the local machine or pass them on to another machine and so on. And there's a lot more going on with this, right? There's the whole question of routing. If this machine tries to access a machine with a given IP address, how does it get there? How does it know what route it should take to send it there? So there's routing tables kept on machines. And another question is, if I try to connect to clark.edu, well, what's the IP address of that? Because these addresses are 32-bit binary numbers. So something needs to resolve that name into an address. So there's domain name servers, DNS servers, that manage name resolution. And so there's a lot of parts and pieces, but most of it you can find in these old RFPs from, typically the 80s. And there's still, a good document that really describes basically what's going on from the lowest levels on up. And then, we ran out of address space, so now we talk IP version 6. And that's a much wider address space. So if I just look at my local machine, actually, let's go to Linux server. And if I say ifconfig, here's the internet address of the Linux server. And it's the 32-bit machine, right? And it's received 17 gigabytes and it's sent 47 gigabytes. It's been a busy machine. But it's been up for a little while. It's been up for 259 days. But that's a good amount of traffic. So on my machine, if I do an ifconfig, I can see my INET 6 address, and it's just a much longer binary number. All right, so that's just a little bit about TCP/IP and routing and stuff like that. Like I say, none of that is going to affect PA5, right? Server sockets and sockets are really all we need. Print writers and scanners and PA4. But I don't know another course where this stuff is kind of introduced. I know courses where it's assumed that you know all this, and people will start talking about, you know, IP addresses and so on. So I just wanted to kind of have that out there as background.
That's cool that there's a default server socket in C#. I don't know if it has one, but you would have to just use this a regular socket and bind it as a server or bind it as a client.
Okay. So yeah, in C, when you want to do a server, you make a regular socket and bind an address to it, as well as a port number. And then if you say listen, then it'll start listening for connections. In Java, it's a separate class for a server socket versus a regular socket, just called a socket, and that simplifies some things. But the whole idea of using objects and classes is that, you know, there's a lot of code you would have to write in C, for example, even more in assembly language, to create a server socket. Well, with objects, we can take all that code and we can bundle it inside this one class, and it lets us do something like, say, you know, construct a server socket with port 1234. And a bazillion lines of code and function calls have happened, and data structures in the operating system have been updated to end up with a socket that's listening for connections. And so this idea of encapsulation and information hiding, right, comes out really nicely when we're at this level, and it's going to get even more extreme around week 9. We're going to start playing with the URL class, I think, and then it's going to be, you know, you type 5 lines of Java and you've got a web browser almost. So
It's URL will be like your HTTP request, right?
yeah.
Gotcha.
Yeah, you can look at the URL class and construct it with a URL, and it gives you, you know, access to the web server. And there's types of content panes, scroll panes that you can hook up that will basically render a HTML page in the expected format. So it's pretty sweet. Alright, I promised you we'd talk about radio buttons in Eclipse, because we're going to need to do radio buttons to decide in the beginning of PA5 whether you're the client or the server. So if you've ever had, you know, a sweet older car with a radio inside, old school radios, right, they had mechanical dials you could turn, and little needle would move back and forth showing you what frequency the radio was receiving. And these had presets in them. And so there were usually, you know, 5 or 6 little plastic buttons, and you could push a button in and the dial would jump to some preset location. And you could press a different button and that first button would pop out, the second button would depress, and the dial would jump somewhere else. Right? And these buttons were programmable. You could turn the dial to pick a frequency for your favorite station, and then grab one of the buttons and pull it out, and then push it back in, and that would lock in the dial, right? So that any time that you push that button, dial will jump back to that frequency. And so these types of buttons where you have a set of them and pressing one causes the others to be unpressed, they're called radio buttons. And so we can do this, and we want to do this for the client-server selection in PA5. And they're really easy to set up in Eclipse, but you need to know one trick, so I just want to show you what that one trick is. And if you don't know this trick, it's not a big deal. It's just they don't act like radio buttons. They just act like, you know, round checkboxes. So let's make a new project. I'll call it RB for radio button. And we'll make a new other, and we'll do a J-frame. And I'll call it, you know, main. Alright, so I'm going to go to the Design tab, and I'm going to drop down my Absolute Layout Manager, as usual, so that I can place things where I want. And here's a radio button. I can take this and I can drop it right here. And I can give it a label, like, you know, Station 1. And I'll take another radio button and put it here. And I don't know what that's going to be, you know, news. And here's my third radio button, and this will be, I don't know, this will be my jazz station. Station 1's kind of weak, man. Let's change the name of that. So I can come under properties and I can change this. So this will be, I don't know, what's my other favorite genre of music? This will be, yeah, we'll do KEXP. Alright, so if I run this, right, I'll get my frame with these three options, but they're not radio buttoned, right? I can select or unselect them at will, and, you know, they don't seem to be related to each other. And that's sad. So to make these work correctly, all you got to do is right-click on the button, come down here to where it says Set Button Group, and if this is the first time you're doing it, it'll say None. Go ahead and say New Standard. So we're going to create a button group. And I can look in here and I can see button group. So I have one button group called Button Group. Alright, so now I'm going to select the second radio button. I'm going to say Set Button Group. I'm going to choose Button Group. And if I do that, my first two radio buttons now work the way I expect. If I select one, the other one gets deselected. Now my third one has no effect on those because it's not part of the button group. So if I come in and I also take this third one and I say Set Button Group and I do the same button group, now I've got three honest-to-goodness radio buttons, and exactly one of them will be selected at a time. And if I want a default station, let's say I want KEXP to be my default, I can pick that button and I can change the selected property to be true. And now when I run this, that button is selected by default, and I can switch another one. Alright, if I want to respond to these changes, and I don't think we need to do this for PA5, because PA5 you're just going to select either, you know, client or server, and it doesn't really matter what you select. No, it does. So as soon as you change one of these, the interface is going to change. So how do we respond to that? Well, right click on this, add an event handler, and let's go down to item state changed. And we'll find a set of code here. And my radio buttons, I'm going to do one other thing here. I'm going to change the names of my buttons. Because right now this button is called Red Button Station, and this is Red Button News, and this is Red Button Jazz. So I'm just going to call this button 1. I'm going to call this button 2. This is just like ignore professor's instruction day, because now I'm using really bad variable names. So here's button 1, button 2, button 3. Alright, so I'm going to add my event handler for item state changed. I'm going to put my VWrapper back on. So a radio button has been selected. Which one? So let's just do a bunch of print statements. So button 1 is my first button. I can call a method called isSelected. And isSelected will tell me if that button is selected or not. So I'm just going to put a print message in here, right, which basically says, let's see what B1 is selected, B2 is selected, and B3 is selected are. And this is where I'm going to start getting into some funny business with Eclipse. I've got squiggly lines under B2 and B3. Why is that? Well, it says B2 is selected is false, right? It's can't resolve. And so, what should we do here? B2 is defined down here. So I'm going to leave the construction where it is because I don't want to mess with that. But I'm going to change the declaration of B2 and B3 to the top. So I'm going to say, and I'm going to do B1 also. It's not a butron though. So it's unhappy because B2 and B3 may not have been initialized. Oh, this can get annoying.
I think you do have to move everything up.
Yeah, alright, I'm gonna...
Declaring B2 below it as a new radio button.
I'm gonna cheat.
I think I had to relocate a lot of my stuff when I was doing the dots game.
Yeah, so I'm just gonna lowball this. I'm just gonna put a separate print message inside each one. Because the other possibility I'm gonna run into is this might get called before the button has been constructed. And so we've got to check for null buttons and so on and so forth. But I just want to show this item state change method. So if I do this, I can run it, and now if I, right, button 1 is selected right now. If I click this one, it'll tell me button 1 is false, button 2 is true. If I do this, it'll tell me button 2 changed to false, button 3 changed to true. If I do this, button 3 changed to false, button 1 changed to true. So you can respond to these events. And you can look up the documentation on a JRadio button and see all the different methods that are available. And it's an extension of a bunch of other classes. So if we say doc JRadio button, it's it doesn't actually have a whole lot of methods itself, but it's got a lot of methods that are inherited, including adding the action listeners and seeing if it's selected, and enabling it and disabling it, and so on and so forth. So, but the main punchline here is you know, in the design window, pick your buttons and just add them to a button group to make them so that only one can be pressed at a time. So that's for the client server selection in the beginning. All right, good on that. All right, we've got about 10 minutes left, and I did a longer discussion on this yesterday, but I'm going to just mention it in here for what it's worth. I just want to make a few comments on the subject of burnout. And you know, we're at the end of spring quarter. We're halfway through week 7, and then we've got, actually we're in week 8 right now. So we've got, you know, 2 weeks left after this, and then a week of finals. And then, you know, for a lot of you, graduation, and then maybe summer classes, and, you know, August, starting at a university perhaps. So I'm hearing from a lot of students, and I'm seeing a lot of discussion in Discord, and I'm just kind of getting through the ether a lot of uh, messaging from students about burnout and feeling done, and doubts about being able to finish and needing a long break and all this kind of stuff. And I just wanted to kind of address that for a few minutes and just make a few comments. Starting with, this is a real thing, right? It's not just, I'm really tired because I didn't sleep much last night. It's like school is hard, right? And school in a computer science program or an engineering program is really hard. Um, and in some senses, the first 2 years are worse. Now, there's certainly going to be really challenging classes at a university, and on any given day, you may find that you're feeling like this is an impossible workload. But the first 2 years is really where a lot of people are learning a lot of the foundational material, and that's sort of the most challenging in its own way. Learning computer architecture, assembly language, digital logic, data structures at the level of C, and so on is just it makes Java look like a joy once you understand Java, because you can sort of just kind of ride this whole set of skills that you've built up. And there'll be other challenges, that will feel just as hard. Math is definitely a big toll, right? There's depending on where you start in math, there can be over 2 years straight of math courses, right? Math every quarter for over 2 years. Physics, I don't need to tell anybody that that's a lot of work. And that's a year of calculus-based physics. When I was undergrad, physics was 2 years. It was 4 semesters. And here it's packed into, 3 quarters. So that's an intense part of the process. So it's definitely real, right? There's maybe a few people for whom this stuff comes easy, but for almost everybody else, right, this is a hard undertaking. And the next part of that is like there is a point of completion, and for most people that's pretty close. And if it doesn't feel close, it may be closer than it feels. And if it's not here yet, if you've got more coursework to do, right, it's still getting closer. And so not giving up, and not even bothering with imposter syndrome and all of that stuff, which is a whole nother topic. But everybody thinks that they got into whatever they're doing by mistake at some point or another. I've had plenty of moments where I was like, I got this teaching job because they really needed someone and they didn't really bother to see if I could teach. And every job I've had, everything I've done, there's been moments where it's like, oh, people just haven't figured out that I don't know what I'm doing. And that's entirely human. And you don't want to dismiss that, but you need to understand that like that's just how we cope with stress sometimes. But if you're feeling like you've reached the end and you don't know if you can keep doing this and so on, I mean, my only suggestion would be suggestions would be definitely talk to someone, friends, family, counselors at Clark, teachers, advisors, whatever, right? Just kind of talking it through can help, bring some clarity on what's really going on. Am I really doubting that I want to do computer science, or am I just looking for a good night's sleep for the first time in a year and a half, right? Sometimes taking some sort of break can be really helpful. And that could be, in the form of one weekend when you do nothing related to school, right? And for a lot of people, that hasn't happened in a long time. But it's definitely a challenge. You've got to follow schedules when assignments are due and so on and so forth. But I guess all I'm saying is, if you have an opportunity to catch your breath, If you can take advantage of that, that's usually helpful. And there's times when you have to kind of put your head down and push through, and there's also times when you need to say, hey, you know, I'm going to do less than my best on this assignment, and that's okay, because I really need to, you know, find my focus. I really need to take care of some other stuff in my life and get those ducks in a row so that I can, you know, do a better job with some other stuff. So just want people to know that, like, you know, I know this is going on. This is an entirely expected thing to have going on for most people. If it's not, that's awesome. But for most people, you know, this is to some degree always there. And it's entirely, you know, something that can be gotten through. But if it feels like that's not happening, or you're not sure about it, right? Let me or somebody know. And you know, there's resources, there's techniques, there's things you can do to sort of adjust and help deal with this stuff. So anyway, I just wanted to toss that out there because, you know, we're coming up to the last 2 weeks of Clark for a lot of people, and so that's good. And if you're moving on from Clark to your university, it's going to be really cool. There's so much cool stuff out there to learn, and so many fun courses to take, and interesting courses, and they're hard courses, but I think they're very rewarding. And if this is something that you enjoy doing and you want to get better at, right, it's going to be a really cool ride. So anyway, I just wanted to leave you with that. So that's all I got for today. So Thursday, I want to go through the other end of this client server side and talk about, you know, creating a socket for a client and then run some Java code that does both ends of the connection and lets you communicate back and forth. And then we'll tie that into threading, and then we'll do some pseudocode for PA5 and get a little more detailed on how all of this ties into turning dots into net dots. Let's see, office hours again. So office hours, Tuesday morning from 7 to 9, Thursday morning from 6:30 to 9, and Friday morning 7:30 to 8:30. And you can find them on, yes, there's a helpful link. Thank you. engrcs.com/schedule. All right, that's all I got. If I don't see you in office hours, I will see you on Thursday in class. Have a great afternoon, and I'll catch everybody next time. Thanks.
Have a great day, everyone.
Thanks,
Thank you.
have a good one.
Take care.